Welcome to Naradar Academy. In this video, we are going to discuss about inverse Laplace transform. Already I have posted one video regarding Laplace transform. I have given the link in the description box. First you go through that video thoroughly, then you can start with this video. Okay, right. Now let's see some formulas for inverse Laplace transform. L inverse of 1 by s minus a is e power at, and L inverse of 1 by s plus a is e power minus at. So here if you have minus it will be plus, if it is plus here it is minus. And L inverse of s by s square minus a square is cos h at, and L inverse of a by s square minus a square is sin h at. If you have subtraction in the denominator, it will be hyperbolic function. Okay, and for s in the numerator it will be cos, and for a in the numerator it will be sin. L inverse of s by s square plus a square is cos at, and L inverse of a by s square plus a square is sin at. So if it is addition of terms in the denominator, it will be what? Simply our regular trigonometric functions. And if you have s in the numerator cos, a in the numerator it will be sin. And L inverse of 1 by s is 1, L inverse of 1 by s square is t, and L inverse of n factorial by s power n plus 1 is t power n. And L inverse of f of s plus a is, what you have to do here, it plus a is there, no, that can be removed by putting e power minus at in the front into L inverse of f of s alone. Then L inverse of 1 by a into f of s by a is equal to f of at. So if a is coming in the denominator with all s, then it will be what? F of at. Or simply this can be rewritten as L inverse of f of ks for some constant k. It's equal to 1 by k into f of t by k. And L inverse of f dash of s, derivative, f dash of s is equal to minus t into L inverse of f of s. So if it is derivative means you have to multiply it by minus t, and then you take L inverse of this function. Then L inverse of s into f of s. If you have product s, then it is differentiation, d by dt of L inverse of f of s. And L inverse of 1 by s into f of s. When you have 1 by s, it will be integration 0 to t L inverse of f of s dt. So if you know all these formulas by heart only, you can proceed with inverse Laplace transform problems. Okay, so first you memorize all these formulas. Now let's see some problems involving inverse Laplace transform. So here we are going to find the inverse Laplace transform for all the following functions. The first problem, 1 by s minus 3 the whole power 5. So L inverse of 1 by s minus 3 the whole power 5 is, first you are having s minus 3, no? So this 3 can be, minus 3 can be removed by putting e power 3t. Sorry, it is not minus 3t, it is simply e power plus 3t. Okay, e power 3t into L inverse of 1 by s power 5. Now you are having s power 5, no? So in the numerator you should have 4 factorial, but it is not here. So I am multiplying and dividing by 4 factorial. Okay, because why I am multiplying and dividing? It is like 1 by s power n plus 1. So if I am having 1 by s power n plus 1, the numerator should be n factorial. That is, here it is 5, no? So 4 factorial should be there. So it is not present here. I am multiplying and dividing by 4 factorial. Okay, now look at this. This is like L inverse of n factorial by s power n plus 1. So this is nothing but t power 4. So e power 3t by, what is 4 factorial? 4 into 3 into 2 into 1, isn't it? So 4 into 3, 12, 12 2s are 24. So 1 by 24 into e power plus 3t. Okay, plus 3t into t to the power of 4. So this is the inverse Laplace transform of the given function. Okay, next, second problem, s by s minus b the whole square plus a square. See, here I am having s minus b in the denominator but no b in the numerator. So whenever you have like that, you add and subtract b. So it will be minus b here, and plus one more b you will be having, no? I write it as a separate term. So L inverse of s minus b by s minus b the whole square plus a square, plus I am adding on b here, no? That b is writing, I am here, I am writing that separately. L inverse of b by s minus b the whole square plus b square. Now here look at this term, wherever you have s, it is in the form s minus b. So this minus b can be removed by putting e power bt term in the front. So e power bt into L inverse of s by s square plus a square. So once you have written this e power bt here, this s minus b to be replaced by s by s square plus a square. Plus here this b is a constant, so I can take it outside. But in the denominator you are having what? S minus b the whole square plus a square, no? So I should have a in the numerator. Then only I can apply inverse Laplace transform. So I am multiplying and dividing by a. Okay, right. Now you listen here, e power bt into L inverse of s by s square plus a square is what? Cos at, isn't it? Numerator it is s, no? So cos, denominator it is addition of terms. So cos at plus here b by a into, again here also this b can be removed by putting e power bt in the front. So I have kept it as a common factor here. So e power bt into b by a into, this is what? A by s square plus a square. Already I have removed this b here. So a by s square plus a square, it is simply what? Sin at. Right? So this is the inverse Laplace transform of the given function. Next problem, this is also similar to the previous one. Cs plus d by s plus a the whole square plus b square. So first let me write it as two separate terms. Cs by s, square, s plus a the whole square plus b square plus d into 1 by s plus a the whole square plus b square. Now again look at this term. Here it is simply s, but it is s plus a here. So you have to add and subtract a. So what will you get? C into, C is a constant, no, which we can keep outside. Okay. So C into L inverse of s plus a minus a by s plus a the whole square plus b square plus d into, I am multiplying and dividing by b, because here I am having s plus a the whole square plus b square, no. So that b I am multiplying and dividing here. And write this as two separate terms, s plus a as one term, another term with minus a, right? So C into L inverse of s plus a by s plus a the whole square plus b square minus this a into L inverse of, it will be simply 1 by s plus a the whole square plus b square. Again the same reason, since I am having plus b square, I have to what to do? Multiply and divide by b. Okay, plus this term d by b into L inverse of b by s plus a the whole square plus b square. So throughout all are having s plus a, no, that s plus a can be removed by putting e power minus at in the front for all the three terms. So c into e power minus at into L inverse of s by s square plus b square minus, okay, the c when it is coming inside, it will be c a by b into e power minus at into L inverse of b by s square plus b square plus d by b into e power minus at into L inverse of b by s square plus b square. Now look at this term. This is cos bt. Okay, this is sin bt, and this again is sin bt. So c e power minus at cos bt minus ac by b e power minus at sin bt plus d by b e power minus at sin bt. Okay, that's all. Then next problem, s by s plus 3 the whole power 5. Okay, so L inverse of s by s plus 3 the whole power 5 is equal to, here also what I am doing is adding and subtracting 3, because here it is s plus 3, no, so I am adding and subtracting 3. So first term will be s plus 3 by s plus 3 the whole power 5 minus 3 into L inverse of 1 by s plus 3 the whole power 5. Here 1 s plus 3 I can get cancel. So simply it will be what? L inverse of 1 by s plus 3 the whole power 4 minus 3 into, here this is s plus 3, no, so I can remove this 3 by putting e power minus 3t in the front into L inverse of 1 by s power 5. Now look at this term alone. Here it is s power 5, no, so I should have 4 factorial in the numerator. For that I am multiplying and dividing by 4 factorial. And when you come to this side, here also this e power, this plus 3 can be removed by putting e power minus 3t in the front into L inverse of 1 by s power 4. Here it is s power 4, no, so you should have 3 factorial in the numerator. So multiply and divide by 3 factorial. So 1 by 3 factorial, 3 factorial is what? 3 into 2 into 1, that is 6. 1 by 6 into e power minus 3t into, this is nothing but t cube minus, here 4 factorial means 4 into 3 into 2 into 1, that is 24. So 3 e power minus 3t, t power 4 by 24. So this is the inverse Laplace transform. Okay, then next problem. 1 by s into s minus e. See, whenever you have 1 by s, that is s in the denominator, Laplace, inverse Laplace is given by integral 0 to t. That is, if you have s in the denominator, it is integration 0 to t, L inverse of only this f of s into dt. So it's equal to integral 0 to t 1 by s minus a into dt. But this is nothing but e power at. So e power at into dt. Integration of e power at is e power at by a within the limit 0 to t. Now we apply the limit. So 1 by a into e power at minus e power 0. E power 0 is equal to 1, no? So L inverse of 1 by s into s minus a equal to 1 by a into e power at minus 1. Okay, right. Then next problem. 1 by s into s square plus 4. Here also the same type. I am having s in the denominator. So L inverse of 1 by s into s square plus 4 is equal to integration of, okay, L inverse of 1 by s square plus 2 square into dt. Now this is nothing but sine, isn't it? But 2 is not present here. Here it is s square plus 2 square, no? That 2 is not here. So I am multiplying and dividing by 2. So 1 by 2 into integral 0 to t. This is nothing but sine 2t. So sine 2t dt. Integration of sine 2t is what? Minus cos 2t by 2 within the limit 0 to t. So minus 1 by 4 into cos 2t minus cos 0. Cos 0 is equal to 1. So what I have? 1 by 4 into 1 minus cos 2t. So this is the required answer. Next problem. 1 by s square into s plus 1. Right? Here I am having s square in the denominator. So for removing single s, you have to put single integral. Since s square is there, no, double integral 0 to t, 0 to t, L inverse of 1 by s plus 1 into dt dt. What is L inverse of 1 by s plus 1? E power minus t. So e power minus t, you have to integrate 2 times. So first time when you integrate, it will be minus e power minus t within the limit 0 to t. You apply the limits, it will be minus e power minus t. And when you apply the lower limit, it is minus of minus plus e power 0. E power 0 is equal to 1. So integral 0 to t, 1 minus e power minus t into dt. Now again you integrate. So it will be what? T. Integration of e power minus t is minus e power minus t. So it will be minus into minus plus e power minus t within the limit 0 to t. Now you substitute the limits. It will be t plus e power minus t for the upper limit. For the lower limit, it will be 0 minus e power 0. E power 0 is what? 1. So the answer is t plus e power minus t minus 1. Okay, then next problem. S square by s minus 1 the whole power 4. Okay, so this problem can be done in two different ways. One is, you see, you are having s minus 1 here, no? So in the numerator it is s. Here you can add and subtract 1. Okay, in that way also you can do. Otherwise, if you have s in the numerator, it is nothing but differentiation, d by dt of L inverse of f of s. Since you are having s square here, it will be what? D square by dt square of L inverse of 1 by s minus 1 the whole power 4. Okay, either you can do it in this way, or you can, what you can do? Add and subtract 1. So let me explain first in this way. So d by dt of L inverse of s by s minus 1 the whole power 4. One s I have removed by putting this d by dt. The other s can also be removed by one more differentiation. So d square by dt square of L inverse of 1 by s minus 1 the whole power 4. Now this minus 1 can be removed by putting e power t in the front into L inverse of 1 by s power 4. When you have s power 4, you should have 3 factorial in the numerator. So for that I am multiplying and dividing by 3 factorial. Okay, so this is nothing but t cube, right? So the answer is d square by dt square of 1 by 6 into e power t into t cube. Now you have to differentiate it 2 times. Product rule you have to apply. Okay, so e power t into differentiation of t cube is 3t square plus t cube into differentiation of e power t is e power t. Take e power t outside, it will be 3t square plus t cube. Again you have to differentiate using product rule. So 1 by 6 into e power t into differentiation of this is 6t plus 3t square plus 3t square plus t cube into differentiation of e power t is e power t. So entirely you take e power t outside, it will be what? 60 plus 3t, 60 square plus 60, right? Okay, this is one way of doing the problem. The other way is, I can add and subtract 1 here. This will be somehow simpler than the previous method. Add and subtract 1 here within the squares. So s minus 1 plus 1 the whole square. So when you expand the numerator, you treat this as your a and this as your b. So it will be s minus 1 the whole square plus 1 square plus 2 into s minus 1. That is a square plus b square plus 2ab. Here s minus 1 I have taken as a. Right? So 3 different terms I am having, no? Right. Now here I can cancel square term. So it will be what? 1 by s minus 1 the whole square plus 1 by s minus 1 the whole power 4 plus 2 into, here I can cancel one term. So 1 by s minus 1 the whole cube. So throughout you are having s minus 1, no? So that can be removed by putting e power t in the front. E power t into L inverse of 1 by s square plus 1 by s power 4 plus 2 into 1 by s cube. S square means 1 factorial. Yes, it is there. S power 4 means 3 factorial. It is not there, so I am dividing by 3 factorial. Here it is 2 factorial. So 2 into 1 by 2 factorial. So this is for t, this is for t cube, and this is for t square. So simplify. So within few steps you can get the answer, but in this way also you can do the problem. Okay, right. Then next problem. 1 plus 2s by s plus 2 the whole square into s minus 1 the whole square. You see, you have product of two terms in the denominator, no? Either you can split this entire term by using the method of partial fractions. Okay, I will do it in the other way. So what I am doing here is, I am going to write the numerator as a linear combination of these two elements. Okay, what is there in the numerator? 1 plus 2. Yes, I am trying to write it as some constant into s plus 2 the whole square plus some constant into s minus 1 the whole square. In this way also you can do, otherwise you have to proceed this by method of partial fractions. First you have to split the denominator, then only you can take the inverse Laplace transform. Directly you cannot take the inverse Laplace transform. So that is the step I am doing here. So now you expand the right hand side. A into s square plus 4s plus 4 plus b into s square minus 2s plus 1. Now collect the s square term. S square term means what? A plus b, and collect s term 4a minus 2b plus constant term 4a plus b. Equate the constant terms s term and s square term on left and right side. Here s square term is a plus b. Here no s square, no. So a plus b equal to 0. That is a equal to minus b. Here s term is 2. Here it is 4a minus 2b. So 4a minus 2b equal to 2. Next here the constant is 4a plus b. Here the constant is 1. So 4a plus b equal to 1. Now here I am getting a equal to minus b, no, you put it here. So minus 6b equal to 2 or b equal to minus 1 by 3. Therefore a equal to plus 1 by 3. Whatever answer you have obtained here, you check with this equation. Yes, I have checked, it is true. If it is not satisfied, something is wrong here, you have to redo it again. So yes, I have checked it. I have got the right answer only. So now what I am doing is I am rewriting the given function equal to, the numerator can be split up into a into s plus 2 the whole square, that is 1 by 3 into s plus 2 the whole square minus b into s minus 1 the whole square, 1 by 3 into s minus 1 the whole square. Now split the terms. So the first term will be 1 by 3 into this s plus 2 square, it cancel, no. So 1 by s minus 1 the whole square minus 1 by 3 into, for the second term it will be 1 by s plus 2 the whole square. Now you take inverse Laplace transform. So 1 by 3 into, here this is s minus 1, no. So it is e power t into L inverse of 1 by s square minus 1 by 3 into, here it is s plus 2, no. So it is e power minus 2t into L inverse of 1 by s square. This is t and this is also t. So 1 by 3 into t into e power t minus e power minus 2t. Okay, right. Then next problem. S by s square plus a square the whole square. See here you are having s square plus a square the whole, s square plus a square the whole square in the denominator. For problems of this type you have to make use of this formula. L inverse of f dash of s is equal to minus t into L inverse of f of s. So for these type of problem, take the given function as f dash of s. S by s square plus a square the whole square. So if you integrate it, you will get f of s. Okay. So what is the integration of this s ds by s square plus a square? See, I am taking s square plus a square as x square. So differentiate it. What will you get? 2s ds equal to 2x dx. That is s ds can be replaced by x dx. So integral s by s square plus a square the whole square into ds is equal to, instead of s ds I can put x dx by s square plus a square is what? X square. The whole square means what? It will be x power 4. So you cancel 1x, it will be 1 by x cube into dx. So what is integration of 1 by x cube? X power minus 3 plus 1 by minus 3 plus 1. So it will be what? Minus 1 by 2x square. But what is x square? S square plus a square. So the integration of this is minus 1 by 2 into s square plus a square. Okay. Now, what is my formula? L inverse of f dash is equal to minus t into L inverse of f of s only. So this is my f of s, no? So L inverse of f dash of s equal to minus t into L inverse of, this is my f of s. Okay, right. So minus into minus will become plus t by 2 into, here this is 1 by s square plus a square, no? So multiply and divide by a. So 1 by a into L inverse of a by s square plus a square. But this is nothing but sin at. So the inverse Laplace transform for s by s square plus a square the whole square is t by 2a into sin at. Okay, then next problem, s by s square minus 1 the whole square. This is also in the same model as above, that is square of the term in the denominator. Take the given function as f dash of s, you find f of s by integrating this. This integration is also similar to the previous one. So whatever answer you have obtained there, the same pattern will follow here. Okay. So when you integrate this, you will get the answer as minus 1 by 2 into s square minus 1. Okay. So what's the formula? L inverse of f dash equal to minus t into L inverse of f of s. This is my f of s. So t by 2 into what is this? 1 by s square minus 1. That is nothing but sin ht. Okay. Next problem. S plus 2 by s square plus 4s plus 5 the whole square. This is also similar type. Square term in the denominator. So for that you have to take f dash of s equal to s plus 2 by s square plus 4s plus 5 the whole square. Integrate it. This is also in the same pattern as we have discussed above. So I put the integration value directly. F of s equal to minus 1 by 2 into s square plus 4s plus 5. So L inverse of f dash of s is equal to what? Minus t into L inverse of f of s. So minus t into L inverse of minus 1 by, I am rewriting the denominator. See, this is s square plus 4s plus 5, no? You write this 5 as 4 plus 1. Okay, then that s square plus 4s plus 4, I can write it as s plus 2 the whole square plus 1. Okay, right. Then this is equal to t by 2 into L inverse of, this is looking like what? 1 by s plus 2 the whole square plus 1 square. This plus 2 can be removed by putting e power minus 2t in the front into L inverse of 1 by s square plus 1. This is Laplace of what? Sin t. So t by 2 into e power minus 2t into sin t. Then the last problem. This is of different type. This is involving logarithmic function. Log of s plus 1 by s minus 1. So whenever you have logarithmic function, you have to take L. This is our L of f of t, no? So take L of f of t equal to log of s plus 1 by s minus 1. Then if this is L of f of t, what is L of t into f of t? That we have studied in Laplace transform, no? So L of t into f of t is minus d by dt ds of L of f of t. Okay, but this L of f of t is nothing but log of s plus 1 by s minus 1. Log a by b can be written as log a minus log b. Now you differentiate. What is differentiation of log s plus 1? 1 by s plus 1. Minus differentiation of log s minus 1 is 1 by s minus 1. Okay, so this is my L of t into f of t. So take inverse Laplace transform on both sides. So this will be simply t into f of t equal to L inverse of 1 by s plus 1 plus L inverse of 1 by s minus 1. This is e power minus t and this is e power plus t. Okay, so this is what? T into f of t. But f of t equal to what? 1 by t into e power t minus e power minus t. So this is the inverse Laplace transform. That is L of f of t is log of s plus 1 by s minus 1. Then f of t equal to 1 by t into e power t minus e power minus t. Okay, that's all. Thank you.